integration by trigonometric transformation applied to integrals involving product of powers of the tangent and the secant functions, or powers of the cotangent and the cosecant function. At the end of this lesson, you must be able to evaluate integrals involving powers of the tangent function, or powers of the cotangent function, or powers of the secant function or the cosecant function, or integrals involving product of powers of the tangent secant functions or the cotangent and the cosecant functions. In evaluating integrals involving product of powers of the tangent and the secant function of some angle, or the integral of a product of powers of the cotangent and the cosecant function of some angles, the transformation is again done by applying appropriate trigonometric identities. In the case of an integral that involves product of powers of the tangent and the secant function of some angles, the appropriate or relevant identity to be used is the identity where secant squared x is equal to tangent squared x plus 1. For the integral involving cotangent and the cosecant function, then the identity to be applied is cosecant squared x is equal to 1 plus cotangent squared of x. We will be illustrating in the next few slides how the transformation is undertaken in this particular case. When you are given an integral that involves product of powers of the tangent and the secant function, the transformation is carried out such that the resulting integral can be evaluated either as powers of the tangent function or powers of the secant function. Or in the case of an integral that involves product of powers of the cotangent and the cosecant function, again, the transformation is carried out such that the resulting integrals can be evaluated either as powers of the cotangent function or powers of the cosecant functions. Now let us look at some examples to illustrate how the transformation is carried out. So consider this case of evaluating the integral of tangent to the fifth x, secant to the fourth x dx. Here we have product of powers of the tangent function and the secant function. So how is the transformation carried out? In this case where the exponent of the secant function is a positive even integer, regardless of what the exponent of the tangent function is, the transformation is carried out such that the resulting integrals will be evaluated as powers of the tangent function. Okay, so how do we do it? Given this integral of tangent to the fifth x, secant to the fourth x dx, what we do is we split off a secant squared x factor from secant to the fourth x, expressing now this factor as product of secant squared x times secant squared x. Okay, now leave this secant squared x with dx to play the role of the differential of tangent x. This other factor of secant squared x, we will transform using the identity expressing this in terms of the tangent function. Recall that secant squared x is equal to 1 plus tangent squared x. Hence, this integral now is written as integral of tangent to the fifth x times 1 plus tangent squared x times secant squared x dx. And if we are going to multiply these factors, we will come up with the following terms. The integral of tangent to the fifth x secant squared x dx plus the integral of tangent to the seventh x times secant squared x dx. Okay, now at this point, let us have the substitution u to replace tangent of x and the differential du to equal secant squared x dx. Hence, this integral now in terms of u would be given by the integral of u to the fifth. This is your tangent to the fifth x factor. Then secant squared x dx will just be du. So the first term is just the integral of u to the fifth du, and the second term will be the integral of u to the seventh du. And evaluating the integrals, we will have u to the sixth divided by 6 plus u to the 8th divided by 8 plus c, or when u is replaced with tangent of x, then we have the integral given by tangent to the 6x over 6 plus tangent to the 8x over 8 plus c. In this particular example, we will illustrate how the transformation is carried out when both exponents of the tangent function and the secant functions are positive odd integers. In this case, the transformation is carried out such that the resulting integrals are evaluated as powers of the secant function. So for the integral of tangent cubed 2x times secant to the 7th 2x dx, what we do is we split off a linear factor from each of these, expressing now the integral as the integral of tangent squared of 2x secant to the 6th of 2x times tangent 2x times secant 2x dx. Okay, now having done that, this factor involving the tangent function or a power of the tangent function is now transformed, expressing it in terms of the secant function. Recall the identity that 1 plus tangent squared of x is equal to secant squared of x. Hence, tangent squared of 2x can now be expressed as secant squared of 2x minus 1. And this integral given by the integral of secant squared of 2x minus 1 times secant to the 6 2x times tangent of 2x times secant of 2x dx. Or if we are going to apply the factors, then we come up with the integrals. The integral of secant to the 8 2x tangent 2x secant 2x dx minus the integral of secant to the 6 2x tangent of 2x secant of 2x dx. Okay, now recall, if we are going to make use of this substitution, where secant of 2x is to be replaced by u, then the product secant 2x tangent 2x dx will just be equal to du over 2. So that this integral now, written in this manner, where we have the correction factor there, can be expressed as 1/2 integral of u to the 8 du minus 1/2 the integral of u to the 6 du. Evaluating the integral would result to a 1/2 times 1 over 9 times u to the 9 minus 1/2 times 1 over 7 times u to the 7 plus c, or if we are going to substitute back secant of 2x in place of u as given in this substitution, then this integral is just given by 1 over 18 times secant to the 9th of 2x minus 1 over 14 times secant to the 7th 2x plus c. The procedure that we have just illustrated can be extended to apply in transforming integrals involving product of powers of the cotangent and the cosecant functions, where the appropriate identities to be applied now is, as given here, we have cosecant squared of x is equal to 1 plus cotangent squared x, or we can make use of the form cotangent squared of x is equal to cosecant squared of x minus 1. So to summarize what we have just taken up in this lesson, an integral involving a product of powers of the tangent and the secant functions, or product of powers of the cotangent and the cosecant functions given by these forms, can be transformed by applying appropriate trigonometric identities to an equivalent integral that can be evaluated as powers of the tangent function, or powers of secant function, or powers of cotangent function, or powers of the cosecant function.